Okay, welcome back everyone. This is a potentiometer, or you call a real stand. Basically, this whole thing is a piece of material that has a resistance. So first of all, let's check what's the resistance of this guy. Okay, so you plug this into your multimeter, change into ohms range. So you are measuring ohms. This one end here is the black, and the other end I connect to red. So I'm basically measuring this, and you can see that 0.534 K. So this is 530 ohms. When I slide this slider, right, the resistance doesn't change because I'm measuring from end to end. However, if I measure from this point is connected to this metal bar here, and connected to the slider. So if I slide, basically I'm touching different points. So 500, if I slide it to the middle, somewhere in the middle, I will get 200 plus ohms, expected, right? So if I slide nearer to the 0 volt, I should get lesser. So here should be around 100. Oh, let's try. 120, 250, this guy must be 370, I don't know, 400, around there, roughly. If I push all the way, it will be the 500. Oh, so it's a predictable phenomenon, and this is a potential divider. Instead of having a fixed resistance, we can do a sliding, and then we can see the resistance. So are we clear this about how it works? We see the resistance, right? But I haven't seen the voltage, right? So now, instead of measuring the resistance, let me do something different. Let's take the power supply. You know that these two are adjustable. This guy is fixed. Channel 3 is fixed at 5 volts. So I got a fixed 5 volts. Okay? So how to ensure that it is 5 volts? You won't know. You have to measure. Okay? So don't believe that they say 5 volt means 5 volt. Let me measure this. I change to V already. Okay, DC voltage. 5.09, so good. So I got 5 volts, right? Now I'm going to apply 5 volt to one end, and 0 volt to one end, and 5 volt to the other end. Okay? So if I slide it to the middle, what's my voltage? Roughly? This is 5 volt, this is 0 volt, this is roughly 2.5. So I'm going to measure this point to see whether it is 2.5. Plus to the point that I want to measure, and 0 to the common ground. Okay? Common 0. Okay. 2.5 volt. As I slide, you can see my voltage drop. 1.9, 1.7, 1.5, and millivolt means almost 0 already, right? Okay. So you know this, and this is expected, and this is a very traditional way of finding out the relationship between resistance and voltage. So you look at your lab sheet and you try to fill up. Okay. So my starting point, because the moment I press all the way, actually the red line will fall at 2 cm. Okay. So the red line is fall at 2 cm. Can you see this point? Red line 2 cm. So zoom in, then at 5 cm I'll start measuring the voltage. This is definitely 0 volts. So if I shift to 5, okay, I shift to 5, like that. I shift to 5, I will have 0.51 volts here, right? So you just fill in the 51 volt here. And what's the resistance? You don't know, right? Because we are measuring voltage, right? So what to do? Change to power off, and then change to measure with ohms. Then you can measure the ohms. The ohms is dropping because it's actually connected to voltage source. We take out everything to make sure that we're not connected to anything. So what's the final? 54 ohms. So that voltage just now corresponds to that particular resistance. Then after that we go to the second point, it's 10 centimeters. I shift to 10. Okay? Then after that, 10 at 10 is 164 ohms. I fill in the ohms. Then after that, I change the voltage. Power on. That's 1.5 volts. So you always have the volts and the ohms and the volts and the ohms. Make sure that I change this accordingly. Okay, V and the ohm sign. DC V, not AC. Okay? So if there's no questions, after you do finish, you will have 2 rows of values and you can plot your graph. Your graph, you can label the same as mine and draw your own.
Okay.
Okay?
Oh, okay.
Oh. So you can send this to the class?
No problem.
Yeah.